So in this section we're going to look at parallel and perpendicular lines. This is a topic that we use in geometry a lot, but it's also an algebra topic. So parallel and perpendicular lines. Parallel lines in a coordinate plane. The definition is that two non-vertical lines are parallel if they have the same slope. All vertical lines are parallel to each other as well. So let's look at two lines. Y equals 3x plus 1 and y equals 3x minus 4. So they have the same slope. The first equation, if I go up 1 to the y-intercept, and if I count my slope 1, 2, 3 up and 1 to the right, I will get a line that looks something like this. The second line has a y-intercept of -4, but also has a slope of 3, meaning that even though it starts in a different place on the y-axis, it still goes up and to the right at the same rate. So these two lines will never cross. That's the definition of parallel lines for our purposes. And because of the slope, which goes up 3 and to the right 1, up 3 and to the right 1, they will always go up and to the right at the same rate, and they will be parallel to each other. So you can see here that the parallel lines, the y-intercept has no bearing on whether or not the lines are parallel. All that matters is what is the slope. So I can use this to write equations of parallel lines. So I'm being asked to write the slope-intercept form, we know what that is, y equals mx plus b, of an equation for the line that passes through the point -1, -2, and is parallel to the graph of this line. So this line that we have has a y-intercept of -2 and a slope of down 3 and to the right 1. So I want to create a line that is parallel to this line and passes through the point -1, -2. So it's going to be over here, and I want it to be parallel. So what does that mean? That means that I want it to have the same slope. So the slope that I need to write a parallel line is -3. Doesn't matter what the y-intercept is. The y-intercept could be any number. All that matters is that the slope is the same to create a parallel line. So I'm really not even looking at the y-intercept here, just the slope. So my line, the one that I'm supposed to write, has a slope of -3 because it's parallel and goes through the point -1, -2. And it asks for slope-intercept form. Now I can either start with point slope or slope intercept. I like point slope, so I'm going to start with the point slope form. I'm going to say y minus a -2 equals, using my slope, x minus a -1. So y plus 2 equals -3 times x plus 1. Change my minus and negative to a positive. I'm going to subtract that 2 and then distribute. And the last thing I'm going to do is combine my like terms. And there's my equation. So here's my line. Passes through the point -1, -2. Has a slope of 3. And had I done this on graph paper, I should have put a graph on here, we would see that it does pass through -5 as the y-intercept. Okay, so again, when I'm writing an equation that's parallel to another line, the only task that I have is to use the slope that matches the line that I started with. In this case, it was the one that went through -2. And use that same slope with the point that I'm given. Okay, perpendicular lines. Two non-vertical lines are perpendicular if the product of their slopes is -1. In other words, the slopes of perpendicular lines are opposite, that's what gets my negative, reciprocals, that's what gets the 1. So if one line has a slope of -1/3, the other line would need a slope of 3 over 1. Reciprocal and opposite sign, and if I multiply these together, I get -1. So if I had, for example, a line y equals 2x minus 3, down 3, and then my slope is up 2 and to the right 1, any other line with a slope of -1/2 will be perpendicular to this line. Let's use, I don't know, +1. So down 1 and to the right 2, -1/2 creates a line, that looks something like this, and these lines are perpendicular. And perpendicular lines form a right angle. But any line with a slope of -1/2 will be perpendicular to the original line that had a slope of 2. So write an equation of a line that passes through the point -3, -2, and is perpendicular, to the line x plus 4y equals 12. So the first thing I want to do is find the slope of this line. So I'm going to subtract x from both sides. Notice that I'm putting it into slope-intercept form. Divide by 4, and I get y equals -1/4 x plus 3. So I want a line that passes through the point -3, -2, and is perpendicular to this line. So this line has a slope of -1/4. So the line that is perpendicular, this symbol means perpendicular, it shows the right angle. The slope of the perpendicular line has to be the opposite, so instead of negative, positive, and instead of 1/4, I'm going to take the reciprocal. So the slope is 4. I've already been told that the point is -3, -2. Doesn't say what kind of equation I need, so I can do any form I want. Y minus y sub 1 equals m times x minus x sub 1. So y minus a -2 is +2. My slope is 4, the opposite reciprocal of the given line. And x minus a -3 would be x plus 3. So that's an adequate answer, because I can write the equation in any form that I want. So again, let me recap real quickly. If I am looking for lines that are parallel lines, then the slope of the first line is going to equal the slope of the second line. If I want perpendicular lines, then the slope of the first line is going to be the opposite reciprocal of the second line. All right, so how do I determine if lines are parallel or perpendicular? So if I give you two equations, y equals 3x minus 1 and y equals -1/3 x plus 2, again, we don't care about the intercepts, just look at the slopes. Those are opposite reciprocals, so these two lines are perpendicular. X plus 3y equals 6, and 2x minus 6y equals 4. So I can't really tell the slopes in this form, so I'm going to rewrite these. 3y equals -x plus 6, divide by 3, y equals -1/3 x plus 2. This one, I'm going to subtract the 2x from both sides. Divide by -6, I get y equals 1/3 x minus 2/3. These two lines are neither parallel nor perpendicular. They don't have the same slope. Their slopes are opposites but not reciprocals, so these are neither parallel nor perpendicular. Okay? So we'll do a couple of these in class, and that's it.